in section 2.6, doing number 10. So we'll take our time here and do this. Let's see. Y is f of x. Use the provided graph to estimate the value of f prime of 1. So it's kind of hard for you to see it on this because this is so light, but here's 1. And here's 1 this way. But f prime of 1 is right about there. And if I try to make do a straight edge on that, let's see if this should work. Piece of paper here. I want to make a line that looks like the slope of that. So that would be something like this. It looks like it goes up about 2 for 1. So I'm estimating from the graph that the slope of the function at 1 is 2. Okay? Sketch f inverse of x. Well, I like to use points on the graph. For instance, I'm going to the lines here. Let's see, maybe I'll darken these so that you can see them. Should use a ruler, but I think you'll get the idea. So here's a point. Here's the minus 1, 2, 3. And this curve is down 1, 2, 3.6 or something. So this point right there is minus 3, minus 3.6 or so. So to graph the inverse, I'm going to go to minus 1, 2, 3.6 or so, and down 1, 2, 3. And that point should look like it matches right straight across, and it's minus 3.6 minus 3. Let's do this point here. So that looks minus 1 minus 3.2. Minus 1 minus 3.2. So its inverse would be minus 3.2 minus 1. This one is 0 minus 2.5. So I'd go minus 2.5, 0. Match that one with that one. This one looks like 1 minus 1, so I would go minus 1, 1. This was 1 minus 1, so the inverse would be minus 1, 1. Here is 1, 2, 3, 1.3, 3, 1.3, so its inverse would be 1.33. So here is the graph of the inverse. You can see how, and I've labeled at least 3 distinct points, 1, 2, 3, and you can keep going here with these, okay? Based on your work, what is the value of f inverse of negative 1? Well, f inverse of negative 1, that's the slope here. Well, it looks like it's 1/2 from the graph, but we also know if the point here was 1, negative 1, and its inverse place is negative 1, 1, the slope here and the slope here, the slope at A is equal to the slope of the reciprocal of the slope of B at negative 1. So these are reciprocals of each other. Let me say that again. The point on the graph is 1, negative 1. The slope, this is on F. So on F prime, the point is negative 1, or F inverse is 1, negative 1, 1. And the slope at f, at 1, f prime of 1 was 2. So if we go to the pair, go to the opposite end, the y instead of the x-coordinate, in the inverse, and find its derivative at negative 1, so it's going to be the reciprocal of what it was at the a. The b part, if this is a and b, the slope at 1 will be the reciprocal of the slope of inverse at the negative one, the b. Okay, so that was 10. Now let's do 11. And it says to sketch a graph of y equals, make sure you can see that, yeah, y equals, or f of x equals 1/4 x cubed plus 4. 1/4 x cubed, that's a x cubed graph squished and then moved up 4. So we'll make a graph of it. 0.25 x to the third plus 4. I'll do zoom 4. Can't see it all, so zoom 6. And then to make it not distorted, I'll square it up. Zoom 5. Okay, so that's what it looks like. And why is this invertible? Well, it is 1 to 1. For every x, there's 1. For every x, there's 1 y. And for every y, there is 1 x. So it's 1 to 1. It passes the vertical line test, and the horizontal line test is another way to say it. And there's values for all x's, and there's values for all y's. So it's on to. Okay. Let G be the inverse of F. And determine a formula for G. So to do that, we replace the y, the f of x, y, with x and change the x to y. So to do that, we would have x equals 1/4 y cubed plus 4. To solve for y, we can multiply by 1/4 right away, or we could subtract 4 right away. Either way. I'll subtract 4, so that'd be x minus 4 equals 1/4 y to the third. I can multiply both sides by 4, and I would get 4x minus 16 equals y cubed. I can then take the cube root of both sides, and I get y, which in this case is g of x, or f inverse of x, and it would be the cube root of 4x minus 16. So there's the formula of G, and then we could find, then it says compute G prime of that and F prime. So F prime of x, so that would be 3/4 x to the 2 plus 0, and G prime of x, so this is to the 1/3 power, so it'd be 1/3 of this to the negative 2/3 power times, oh, I should have taken times the derivative of the inside, which I could do first or now. Derivative of 4x minus 16 is just 4. So I get 4/3, and I could put this, because of the negative, in the denominator and take the cube root of 4x minus 16 squared. Okay, so here's f prime of x, and here's g prime of x. Now it says find f prime of 2. So if I put 2 in there, 2 squared is 4 times 3/4. F prime of 2 is 3. Then it says, what's g prime of 6? Well, looking ahead, what is f of 2? If I put in 2, 2 cubed is 8. 8 divided by 4 is 2, plus 4 is 6. So if I put 2 into f, I get 6. If I put 2 into f prime, I find the slope of this at 2 is 3. And if g is the inverse of this, I should be able to put 6 into g prime and get the reciprocal. If I put 2 into, if I find the slope of f at 2, then the slope of its inverse at 6 will be 1/3. Let's check and see if we get 1/3. So g prime of 6 would be 4/3 cube root of 4 times 3 minus 16 squared. 4 times 3 is 12. 12 minus 16 is minus 4. Minus 4 squared is 16. Oops, I'm not getting what I want here. What did I mess up here? Let's see. 1/3 of this to the minus 2/3. So minus 2/3, the 2 and the third. So times 4. I'm not getting 1/6, so I've got arithmetic error. What did I do? So I subtract 4, then I multiply by 4 for x minus 16. So 1/3 power. Okay. So if I put in 4, no, put in 6. Oh, that's what I'm supposed to put in 6. 4 times 6. There's my mistake. 4 times 6. 4 times 6 is 24. Minus 16 is 8. There's my mistake. 4 times 6, 24. Minus 16 is 8. 8 squared is 64. Cube root of 64 is 4. So the 4's cancel, and I get cube root of 64 is 4. 4's cancel, and I get 1/3. Reciprocal that 1/3. For some reason, I was thinking 1/6 is what I was looking for. It's 1/3. So there, I finally got it straight. I put the wrong number in for x. I don't know why I put in 3, because it says I'm supposed to be putting in 6. Putting in 6. So, got the reciprocals. Okay, number 12. So, h, this is number 12, and I'm supposed to do, we have h of x equals x plus sine x. And it says sketch a graph of that. X plus sine x. Zoom 4. And it says, explain why this is invertible. Well, once again, it looks like it covers all the x's and all the y's, so it's onto. All the y's have all the y's have x's and all the x's have y's. It passes a vertical line test and it passes the horizontal line test, so it's 1 to 1. So it should be invertible. Explain why it does not appear to be algebraically possible. Well, if this is y, and if we were trying to find h prime of x, then we would be swapping the y and x, so we'd have y plus sine of y equals x, and there's no way to factor out a y out of this, because this is a function, it's not times y. So we can't factor out a y, we can't do anything. This is algebraically really tough to do at this level. So for us, it's basically does not appear algebraically possible. Okay? Now, if you learn some later tools, you might be able to solve it. So they say, observe that pi over 2 gives you pi over 2 plus 1. Well, if we put pi over 2 in for the x's, sine of pi over 2 is 1, and so we get pi over 2 plus 1. So if we put in pi over 2, we get pi over 2 plus 1. So the slope at pi over 2 for h will be the reciprocal of the slope of the inverse at pi over 2 plus 1. So even though we can't figure out h prime of x, we have no way of getting that equation. We do have a way of getting the slope of that equation, whatever it is, because we know it's the reciprocal of the slope of h at pi over 2. So we're going to find the slope of h. Oh, this is inverse. We're finding the inverse. And we can't get that one to go anywhere. That one's unsolvable for x. For y. So we can't get y by itself. So the slope of h, so now we're going to, so we can't find that. So we're going to find the slope of h at pi over 2. Well, h prime of x is the derivative of this, which is 1, plus the derivative of sine is cosine of x, times the derivative of the inside, where the derivative of x is 1. So that's it. And we put in pi over 2, and h prime of pi over 2 will be 1 plus cosine of pi over 2, which is 0. So the slope of this graph is 1 at pi over 2. So its inverse, which we are not able to find, can't turn this one around, but we know its slope at pi over 2 plus 1 will be the reciprocal of 1, and 1 flipped over is still 1. So we know its slope will be 1. Okay?